Hey, before I start, I want to thank Blackpenredpen for making this contest. I love the 100 integrals, they're great, and Blackpenredpen, your channel, has fostered my love for calculus so much. So thank you, and I love the community around this. It's a lot of fun.
Hello everyone, today we're going to be integrating cosine squared of 2x dx. Okay, so I know this integral may seem trivial to some of you if you know how to do the trig sub, but I have a method to do this that is very different, as I've seen Blackpenredpen doing the complex definition of sine and cosine. So we can use those to do this, and it's really nice. So to start to make things easier, we can let 2x equal u. So this is a very straightforward u substitution. Du on dx is going to just be 2, and then we can bring a 1/2 out of the integral to integrate with respect to u. And now, this is the point where most people do the trig sub, but rather than trying to reduce the power of cosine, I'm going to actually derive the complex definition of cosine. So over here, we know that e to the I theta is equal to the cosine of theta plus I times the sine of theta. Now, what happens if we plug in a negative theta? Well, e to the negative I theta, cosine is an even function, so it's going to stay the same, it's just cosine theta, and sine's an odd function, so we have minus I sine theta here. And now we can add these two equations together. So now we have that e to the I theta plus e to the negative I theta is equal to 2 cosine theta, because these two pieces cancel each other out. And dividing by 2 on each side, we now have a way to write cosine theta in terms of e to the I theta and e to the negative I theta. So now we can come back to the integral and substitute it in. So we're going, it's just this thing squared. So e to the I theta plus e to the negative I theta, all on 2, squared. And we could just say u equals theta. It's just a change variable, but the variables are the same thing, so it doesn't matter. We could call it whatever we want. So then, the top's being squared and the bottom's being squared. And 2 squared is 4, so we can bring a fourth out of the integral, and a fourth times a half is an 8. So we'll get an eighth times the integral of the numerator squared. So we have to e to the I theta squared is e to the 2 I theta. And if you imagine squaring this out, you have e to the I theta plus e to the negative I theta times e to the I theta plus e to the negative I theta. So we have to do these two, and these two. So e to the negative I theta times e to the I theta, you just have this in the denominator, so it equals 1. E to the I theta and e to the negative I theta also equals 1, and you have 2 of them, so you have 2. And then these two, e to the negative I theta times e to the negative I theta, is e to the negative 2 I theta. And now that we have this, we know how to integrate this. Because in the complex world, I is a constant. So this is just the integral of e to the, so now we can actually do the anti-differentiation. So we're going to have, what is the, what is the derivative of e to the 2 I theta? It is an exponential, so we know that it's e to the 2 I theta, but if you were to differentiate this, you have a 2i hopping in front, so we need to divide by it. And then we have the same thing here, so we have e to the negative 2 I theta, I'm doing this one first, and then we need to divide by negative 2i. And then 2 theta, the integral 2 is just 2 theta. And of course we can put the plus z. So, now that we have this, we need to think about how can we put this back in terms of our friends cosine and sine. So, let's come back over here, and instead of adding these two equations, let's subtract them and see what happens. So now when we're subtracting them, we get that e to the I theta minus e to the negative I theta is equal to 2i sine theta. And now we can have an expression for sine theta, and that sine theta is now going to be e to the I theta over 2i minus e to the negative I theta over 2i. And look at what we have here. We have e to the 2i theta over 2i, and this minus in the denominator we can bring up front here, minus e to the negative 2i theta over 2i. This is the same thing, except here we have I theta, and here we have 2i theta, which means this is nothing but sine of 2 theta. So now we have sine of 2 theta plus 2 theta. And when we distribute through, and remember, theta was u, and u is 2x, so we just have sine of 4x over 8 plus 2 times 2x over 8, which is just 2x over 4, which is just x over 2, plus c. And 我们做完了 we are done.